Hi everyone, there are some important questions for you that are very important for board questions. So let's start the lecture. Okay, first of all we should know quantum numbers, then we can solve the questions. Okay, so here questions are: calculate highest electron capacity or number of orbitals of the system by determining value of L and M, right? Then show the orbital numbers of n shell, I mean outermost shell, in the stem is equal to n square by calculation, right? And then last question is that show that electron numbers of n shell in the stem is equal to 2n square by calculation, right? Okay, so first of all, for this lecture, I mean for this problem, we should know four quantum numbers. Okay, four quantum numbers are n, l, m, s, right? What is n? N means principal quantum number. What is principal quantum number? I mean the principal quantum number is that this is first shell. For first shell n equal 1, for second shell n equal 2, for third shell n equal 3, for fourth shell n equal 4, for fifth shell n equal 5. This is n equal 1 according to Bohr's atom model, then this is n equal 2, then n equal 3, n equal 4, n equal 5. Okay, generally n describes as the principal quantum number or principal shell or main energy shell or orbit or 2D circular path of having electron, okay, or path of rotating electron. Okay, so n is equal at n may be 1, 2, 3, 4, 5, 6 respectively. Okay, and also they are denoted by k, l, m, and k. For n is equal 1, it should be k, l, m, n, o, right, respectively. Okay, now here n should be an integer 1, 2, 3, 4, 5, 6. Okay, and they denote generally, they indicate generally first shell, second shell, third shell. Okay, main energy shell, right? So n should be any positive number, I mean from 1 to, okay, so mathematically n should be any integers, right? So n is main energy shell or main orbit. Okay, main, not only main energy shell, they are also energy shells, maybe 1, 2, 3, 4 respectively, any number. Okay, so here n should be 1, 2, 3, 4. Okay, and origin of n is from Bohr's atom model. Okay, so according to Bohr's atom model, electron rotates around nucleus in any circular path. Okay, and this circular path should be 1, 2, 3, 4, 5, also k, l, m, n, o, p. Okay, respectively, any letters or any numbers. Okay, so you have already known n, right? Now second orbital number is that l. L means azimuthal or subsidiary quantum number. This is principal quantum number. Principal quantum number. This is azimuthal or subsidiary quantum number. Subsidiary quantum number, right? Quantum numbers, right? Quantum numbers, subsidiary or azimuthal quantum number. This is magnetic quantum number and this is spin quantum number. Okay, let's calculate some basic concept here. I mean we have already known n. Right now, what is L? L means subshell. Subshell may be S, P, D, F. We know what is s orbital. S orbital is spherical, right? So 3D, this is just like football, right? 3D. And what is p orbital? P orbital is a dumbbell shaped. Dumbbell shaped means there are two lobes. Okay, it may be px, it may be py, it may be py, or it may be pz, right? Pz orbitals. So pz orbitals. So there are three types of orbital: px, py, and pz, right? And there are also 5d orbitals. 5d orbitals means there are 5d orbitals. So they are denoted generally dxy, dyz, dzx, dx square minus y square, dz square. I mean here s orbital is spherical shape, right? S orbital is spherical, 3D. So just like a football. P orbital is 3D, I mean dumbbell shaped. So it may be three types. This is px, this is py, and this is pz, right? What is d orbital? D orbital is double dumbbell shaped. I mean dxy, dyz, dzx, dx square minus y square, dz square, right? There are 5 d orbitals and 7 f orbitals. So d orbital has 4 lobe or 2 lobe, I mean 4 lobes here. Dxy, support dxy, xy, this is x axis and this is y axis, right? So this is dxy orbital. Dyz, similarly we can draw dyz. Dyz is like that. Suppose this is y axis and this is z axis, so yz orbital dyz like this one. Okay, dzx, dzx, I mean this is x orbital axis, or this is z axis, then dzx means like this one. Okay, double shift. Now dx square minus y square dz square. Dz square is like that, dx square minus y square. Then suppose this is x axis and this is y axis. Okay, so dx square minus y square is along direct axis. Okay, this is x axis. Okay, dxy like this one. Okay, now what is dz square shape? Dz square shape is that, I mean suppose this is x and this is y and this is z. This is z axis. So there is a ring, 3D ring, and this is also like this one. Okay, this is dz square. Okay, so there are 5d orbitals. So now also there are 7f orbitals, but we should know first of all what is L. L means shell, subshell or orbitals. So L may be any subshell, s,p,d,f. For L, value should be 0 to n minus 1, 0 to n minus 1. Suppose n is equal 1, and L should be 1 minus 1, I mean 0. Similarly, we should know some value of s. S should be 0, 1, 2, 3, right? So 0, 1, 2, 3, value of SPDF 0, 1, 2, 3, right? For n equal 1, L should be 1 minus 1, that means 0. 0 means 1s, right? So for n equal 2, L should be 0, 1. Because if you put here n here, I mean 2 means 2 minus 1 means 1, right? But L should be 0 to n minus 1. That is why L should be 0 to 1, 0 to 0, 1. I mean 2s, this is 2p, right? Because value of L s is 0 and p is 1, right? So 0 to 1, 0 to 1. For n equal 3, L should be 0, 1, 2, 0, 1, 2. For n equal 3, so 3s, 3p, 3d. For n equal 4, L should be 0, 1, 2, 3. So here 4s, 4p, 4d, 4f, right? So first of all, you should know what is L. L means orbitals, I mean subshell. So it depends on L. L should be 0 to n minus 1, 0 to n minus 1. So for n is equal to 1, L should have only one value, that is 1 minus 1 means 0. For n is equal to, L should have two value, right? 0 to 1, 0 to 1, because 0 to n minus 1, 0 to 2 minus 1 means 1, so 0, 1. For n is equal to 3, L should be 0, 1, 2, because 0 to n minus 1, 0 to 3 minus 1, 2, so 0, 1, 2. Similarly, 0, 1, 2, 3, 0, 1, 2, 3, and value of SPDF are respectively 0, 1, 2, 3, right? So L should have also GH, okay, for higher orbitals, but we should know minimum this 4 orbitals, and value of n should be minimum 4 types, I mean 0, 1, 2, 3, 4, right? Now we have already known n. What is n? N means shell means energy shell, orbit. Okay, so n should be 1, 2, 3, 4, 5, 6. Okay, K, L, M, N, O, P, right? Then what is L? L denotes especially orbitals should be 4 types here. For our general purpose, we should know minimum 4 orbitals, S, P, D, F, and value of S is 0 and P1, D2 and F3. Okay, they are arbitrary basically. So 0 to n minus 1, 0 to n minus 1, L value of L should be 0 to n minus 1. For n is equal 1, L should be 0. For n equal 2, L should be 0, 1, because if you put 2 here, you get 1. But L should be 0 to n minus 1, that is 0 to 2 minus 1 means 1, 0 to 1. For n is equal 3, L should be 0 to n minus 1, 0 to 3 minus 1, so 0, 1, 2 respectively. For 4, n should be 4, should have 4 value, right? 0 to 3, 0 to 3, and that is 4s, 4p, 4d, 4f, because y as pdf, value of s should be 0, p should be 1, d should be 2, and f should be 3. 0 to 3, right? So we have already known n, l, l. Now for m should have value of minus l to plus l. M depends on minus l, 0 plus l. This is very interesting. So for solving this question, we should know about L and M, right? So I will draw a map here. N, this is L, this is M, this is S. Also we should know orbital numbers and electron numbers. Okay, now we should know what is n. Okay, now we already have known n and l, right? For n is equal 1, n should be 0 to n minus 1. So 0 to n minus 1, 0 to n minus 1. So this is 0, right? Again SPDF, value of s is 1, 0, 1, 2, 3, right? So this is 1s, right? 1s. Okay, now m should have 0 to minus l, 0 plus l, but here for 0, minus 0, 0 plus 0, this is impossible. That is why only 0, right? Okay, now what is n for n equal to? For n equal to and for n equal 3. Suppose for n equal to, l should have 2 value, right? I mean 0, 1. This is 2s and 2p. Okay, then value of m should be 0, but for this one value of m should be minus 1, 0, plus 1, right? Okay, now for this one okay, for this one n equal 3, for n equal 3, l should have 0, 1, 2, 3, 0, 1, 2, 0, 1, 2. I mean this is 3s, this is 3p, and this is 3d, right? For n is equal 4, l should have minimum 4 value. That is I mean here, okay, for n is equal 4, this is 0, 1, 2, 3, 4s, 4d, 4s, 4p, 4d, 4f, right? So l should have 4 value, 0, 1, 2, 3, 0, 1, 2, 3. Now this is 0, this is minus l, 0, plus 1, this is minus 2, minus 1, 0, plus 1, plus 2, right? Similarly for this is 0, this is minus 1, 0, plus 1, this is minus 2, minus 1, 0, plus 1, plus 2, right? For this one minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, so here goes. Now what is s? S means spin quantum number. I mean, please note down here, that is value of m should have should be equal to number of orbitals. I mean here there is only one value of m and s, that is why there is only one s orbital. Okay, so orbital number is 1 here. Number to shell, I mean for n equal 2, right? In second shell there are 2 types of orbital. This is s and p, but how much? And m actually denotes number of orbitals. I mean there are s orbital, 1 s orbital and 3 p orbital, right? So 3 p orbital means px, py and pz, right? So there are 1 s orbital, 2 p orbital, and 3 p orbital, and 5 d orbital, right? And also 1, 3, 5, 7 here, because 1 s orbital, 2 p orbital, 3 d orbital, 5 f orbital, 1 s orbital, 3 d orbital, 5 f orbital, and 5 d orbital and 7 f orbital. Okay, so electron numbers. Now what is spin quantum number? Spin should be plus or minus. So for clockwise spin should be minus, and for anti-clockwise rotation spin should be plus. But for electron, I mean for lepton particles, generally spins are minus half and plus half, right? For electrons, okay. But spin should be any value. For suppose for boson particle, I mean Higgs boson particle, spin is 0, right? For photon spin is +1, for graviton spin is +2. So a spin should be any value, but for electrons spin is only -half and or +half. For clockwise rotation spin is -half and for anti-clockwise rotation spin is +half. Okay, that is why here only one orbital, so there should be 2 electrons according to Pauli's exclusion principle. According to Pauli's exclusion principle, any orbital should have maximum 2 orbitals. That is why here only one s orbital, so there should be 2 electrons, one clockwise, another is anti-clockwise, right, in direction, right? So they are ±half, and this is there are 3 electron, 3 into ±half, right? So here 0 ±half, I mean 3 ±half and 5 ±half. Okay, so similarly here 7 1 ±half, 3 ±half, 5 ±half, 7 ±half. Okay, so okay, you can fill up this one. Now electron numbers, I mean the more orbitals, 2 times electrons, I mean one orbital should have maximum 2 electrons. That is why there are 2 electrons, 6 electrons, 2 electrons, 2 6 10, 2 6 10 14, right? So total numbers of electrons here 2. I mean it follows 2n square formula, because why 2n square formula? 2 times 1 square means 2 electrons. Here show that electron numbers of n shell in the stem is equal to 2n square formula, because here total electrons are 2 8 8 18 18 32, right? 32 total electron numbers are 32, total orbital numbers are 16, right? So this is n square, because here n is equal 4 but orbital number is 4, right? That is why. But for questions, I mean for this one we should only use n is equal 4, not overall graph. Okay, so for solving this question I will show you clear path. Okay, that is for n is equal 4 only we will put 4, for n is equal 3 only we will use n is equal 3, right? So for n is equal 4, okay, now this is n, this is l, this is s, this is m. Okay, now then electron numbers, orbital numbers and electron numbers, then electron numbers, orbital numbers, electron numbers. Okay, now for n is equal 4, we should know, for n is equal 4, right? For n is equal 4, L should be 0 1 2 3, right? 0 10 minus 1, so this is 2s 4s, this is 4p 4d, this is 4f. Okay, so here m means 1 orbital, 1s orbital, I mean sorry, this there should be 0, right? There should be 0 0 minus 1 0 plus 1 minus 2 plus, right? For this is for this one minus 2 minus 1 minus 2 minus 1 0 plus 1 plus 2, right? For this one it should be minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3, right? Okay, now for this one orbital numbers, there are 1s orbital, 3p orbital, 5d orbital and 7f orbital, right? So spin only plus minus half, for this plus minus half, 3 into plus minus half, right? Here 5 into plus minus half, total 10 electrons, 5 in clockwise direction, another 5 is anti-clockwise direction, 7 times plus minus half, right? Okay, now electron numbers 2 times of orbital, 2 6 10 14, right? So total numbers of electrons here are total orbitals. Okay, total orbitals, I mean 16, right? Total electrons 32, right? So total electron numbers follow 2n square. 2n square means 2 times 4 square means 32, right? Also orbital numbers follow n square formula, because n square formula means 4 square means 16, that is why I should you have got the uh, points here. Okay, calculate highest electron capacity. Electron capacity should be n square, 2n square formula, but you can calculate this problem by using quantum numbers n, l, s, m. Okay, so this is very important questions. I mean they are very much important for frequent board questions. So I think all things here are clear for you. Okay, I hope you got the point. Okay, thank you so much.